It's 103. So today I'll be presenting on my journey to Amazon Web Services and my journey in cloud computing, and talking a little bit about what the cloud is and careers and what careers in the cloud look like. My name is Philip Fan, and I'm an engineer in Amazon Web Services for ECS. So what is the cloud? So in very broad outline, very broad definition, the cloud is basically remote infrastructure that is handled by some other group or company that manages one's internet architecture, such as databases and cloud compute. So what did the internet look like before the cloud? So before the cloud, individual companies like IBM or Home Depot, they all had to manage their own internet infrastructure. That would involve owning their own internet servers, hiring engineers to manage that internet servers, database engineers to manage their databases, basically having to own a whole internet stack end to end, from the underlying hardware architecture all the way to deploying this architecture worldwide and ensuring that it's available for people to use across the world. So there's a few problems with that model, in that it requires a lot of specialized knowledge for each individual company to manage their internet architecture. So like if you think about it, like Home Depot, Lowe's, or McDonald's, they would all have to hire a lot of different engineers in multiple areas: network engineers, database engineers, and deployment engineers like DevOps to manage the internet architecture. So the whole paradigm with cloud is that in cloud computing, another company would manage your online infrastructure for you, and you would just need to set up some configurations to get your online presence set up. So why is cloud computing so popular and widespread right now? So there are multiple factors why the cloud has exploded in the last 10 to 15 years. One is price. So with a large company managing your online service, they can leverage economies of scale to ensure that you get extremely low cost in terms of renting out or using online infrastructure like servers, databases. Since, for example, Amazon Web Services, they would have millions of servers that people can use. They can minimize the costs of managing those services by they minimize the cost of managing those services, and like have specialized engineers also managing those services for you. So that results in oftentimes a lower cost than hiring your own engineers to manage your servers, managing your databases, and like deploying your changes for you. So that's one thing with price. Second thing is reliability. So with a cloud provider, they often have way more expertise in terms of ensuring that a service is online and like is always accessible to consumers. While if you hire a if an individual company has to build up a team to manage their own online presence, like Home Depot, building up their own online team, uh, they would encounter roadblocks and like issues that would have been already solved by experienced cloud provider like AWS. Reason why the cloud is so popular. Second thing is also another thing is also with warranty and SLAs with cloud computing. So basically, when you use a cloud provider, you enter into an agreement with the cloud provider in terms of like availability of the service that you're renting or using from the cloud provider. So let's say, for example, I'm using a database server, like I'm managing an online server website via AWS. If my website goes down for more than like 10 to 20 minutes or an hour or day, I am entitled to credit from AWS for that uh, for that outage, since that's affecting me and my service. So basically, companies who aren't that familiar with the cloud get a guarantee from the cloud provider that their service is guaranteed to be working to a reasonable degree of safety and reliability, and that they don't need to worry too much about maintaining that reliability, since Amazon has a whole group of engineers dedicated to ensuring that their online service and presence is maintained. And popularity as well ties into the economies of scale. The more customers that onboard onto a cloud service, the more ways that Amazon and other cloud providers like Microsoft Azure or Google Cloud can utilize their economies of scale to build up new services that new customers can leverage and decrease the cost of existing services by utilizing these economies of scale. So that's also why cloud computing is increasing in popularity as the years go by. And the last thing is with scalability. Since cloud providers are, for the most part, very large and have lots of engineers working on it on cloud, there's a lot of different services that's available on the cloud. There's machine on the cloud. You can leverage machine learning workloads. You can set up a web application. You can parse gigabytes of data as you receive that data. So because these cloud providers are so big, there are multiple smaller organizations within these cloud providers that all are building out different features and ensuring that these features are reliable and usable by all the customers. So if I'm a new person or new company starting out in the business world, I can very easily get started up and running with the cloud and scale up to 1,000, a million customers very quickly with the cloud. So there's a lot of pros and on why the cloud became so popular recently in the last 10, 15 years, and why huge companies like Netflix are trusting cloud providers like Amazon and Microsoft with their streaming service. However, there are a few cons with using cloud computing. First is with configurability. So there are a lot of companies, while a lot of companies would be covered by common workflows that are provided by Amazon and Microsoft, there are a few niche services and product areas that wouldn't be covered by a cloud provider like Amazon. One example is with hedge funds and market makers. So these groups, hedge funds and market makers, like Citadel and Optiver, they want to get data from stock market as quickly as possible, at the lowest latency possible. So they they often need to set up their own infrastructure to get this data as quickly as possible, connecting to the stock market uh, data in New York directly. Uh, Unfortunately, Amazon and like other cloud providers, they don't have this feature readily available. So these hedge funds and like market makers, they need to set up this infrastructure and own all this low latency infrastructure themselves, hiring their own engineers. So this example just illustrates how while the cloud is immense and has a lot of different features, not everything is covered under cloud providers like Amazon or Microsoft. There are still a few niche services that customers serve but aren't covered by Amazon. Second reason why there's a con with the cloud is that you're trusting another company to manage your online infrastructure and your customers' data. So uh, for most companies, that is a reasonable trade-off that they're willing to make. However, for a few companies, their customer data is key, and is key to them, and they don't want to entrust another company with managing that data. Um, so stuff like confidential, top secret workflows, for example, that was initially an area where um, like government agencies initially did not want to work with Amazon because they did not trust that Amazon would follow good best practices in terms of security. That story has changed a bit recently with Amazon and other cloud providers partnering up with the government to work on top secret projects. But that's just is this example is just illustrating how companies who have secretive information and don't necessarily want to trust a third party to manage their online infrastructure or data, um, they may decide to just build out their own infrastructure, online infrastructure, to ensure that this data is protected and kept secret. So that's a brief overview of what the cloud is, why is it so popular right now, and uh, cons with cloud computing. So next, I'll be talking about a few common cloud applications. So I'm providing an AWS focused perspective, mostly because I work in AWS and I'm most familiar with AWS in terms of cloud applications, compute, and storage. So storage is just basically how is data that a customer has stored. In each of the cloud providers, there are multiple different services that can be used to store data. So for AWS, there's Relational Database Service, RDS, Simple Storage Service, S3, and DynamoDB. These are all different types of storage solutions offered by AWS. RDS is a relational database service. Uh, S3 is a simple key bucket, is a simple bucket object storage medium, and then DynamoDB is a key value storage option. So basically, these storage options are different ways that cloud providers can store your data for you, depending on how your data is stored. Is it a database? Is it a relational database that needs to be stored with proper with a tight schema, or is it just objects that you can just throw into S3? Uh, all the cloud providers have similar solutions in terms of storage. They just have different naming structures for across all the different cloud providers like Google Cloud and Azure. And then moving on to compute. Compute is basically the second category of common cloud applications. Compute is basically how you you as a customer want to handle the data that you store on in the cloud. So the most common compute services in AWS are EC2, Elastic Compute Cloud, where you can borrow compute power from Amazon using Linux instances or ARM instances or whatever type of instances you want. The next common one is ECS and Fargate, where you can manage Docker containers through a container orchestration platform called ECS, and Amazon would handle running these uh, containerized services for you and scaling them up for you. Um, and last commonly popular compute application is Lambda, and that's a serverless cloud function service that Amazon provides, where it just basically executes a function every time it's invoked on a compute instance that you don't need to take care of or worry about. Uh, so, so basically, all cloud services are a combination or application of these two main categories of compute and storage. So storing, like spinning up a website via a cloud service, would just involve storing the various web pages into various content distribution networks across Amazon, and storing like pictures, customer data via one of these storage options. And then the compute would be the underlying infrastructure that the customer would use to spin up the web service. And there are multiple different workflows, of course, not just websites, machine learning workflows, and whatnot. So basically, though, at a very high level, cloud services are just a combination of compute and storage and different applications of these two main categories. So now I just want to talk about a little bit about the different careers in cloud computing. Um, as a cloud provider, there are a lot of different roles within a cloud organization. Um, these roles all help support a cloud organization, ensure that end to end, a customer is able to set up their cloud infrastructure and get running with a website or their workflow. So I'll just provide a brief overview of what all the cloud roles look like within a cloud company. So first up is a software engineer. These people are the ones who build and manage your software, customer software applications. They build on top of the underlying architecture across Amazon, Microsoft, or Google, and these people are basically the building blocks of a cloud service. Next up is solution architects, and cloud consultants. These individuals work with individual customers, such as like Home Depot, or for example, or Netflix, and see how the customer's needs can be managed by a cloud provider. They work with the customer to ensure to basically bridge the gap between what the customer wants. Let's say they want to spin up a website to what Amazon or Microsoft can provide, and what services they can provide. So they basically give recommendations to customers in terms of how you can structure and use cloud services to set up their online infrastructure. So they play a very important role in terms of working with customers and making sure that they're effectively using cloud providers. Now, the security engineers, these are the people who are responsible security policies are followed and that customer data is kept secure, which is always one of the biggest concerns that customers have, is that they want to make sure that the data that they are giving to a third party, like Microsoft, is secure and that it's protected. And that if an attacker tries to hack into a cloud provider, that this data is protected. So these engineers basically make sure that compliance rules are followed and that we follow best practices in a cloud provider to ensure that customer data is protected. Next up is site reliability engineers. So these engineers are basically the engineers who help deploy changes to the cloud, and like across the multiple different regions that cloud providers operate in. They also are sometimes embedded within the actual server rooms where cloud providers manage their hardware. So these site reliability engineers basically make sure that when things go wrong, like if a power rack goes haywire inside the server room, they are the ones who usually deal with that issue and make sure that the cloud service is up and running quickly as soon as possible. Next up is product managers or PMs. PMs are basically the bridge between customers and software engineers, and in terms of getting inputs from customers and on what new features they would like to see from cloud providers, as cloud providers are always constantly expanding in terms of new features and in terms of new features that can be offered. So basically, product managers work with engineers and customers to ensure that any new feature that gets released or rolled out by a cloud provider is fits within certain specifications and tries to fit within multiple customer use cases. They just basically lead the product direction and ensure that a new product that gets rolled out by a cloud provider is useful to existing customers. And then we have account managers. Account managers are basically just people who are assigned to companies, individual companies, and they help manage the relationship between the customer and a cloud provider, ensuring that any issues that the customer sees is communicated to the cloud provider. So if a customer sees a bug with their workflow, this gets communicated to us via an account manager, and then we can handle these bugs and try to get this issue resolved. So that's what account managers do. And lastly, we have support engineers. And support engineers are basically engineers who usually deal with the day-to-day bug tickets or issues that they see from customers. And they try to handle those issues and resolve these customer issues by themselves. If they aren't sure on how to handle these issues, they usually escalate and provide these issues to us, the software engineers, where we can further deep dive into what the issue is and help the customer resolve the issue they're facing. So that was just a brief overview of the cloud and what careers in cloud look like and why the cloud is so popular. So now just a little bit about myself and how I got to my role in Amazon Web Services. So back in high school and college, I mainly took a STEM-focused curriculum, focused on mostly on math and CS at UVA. I was a computer science major, where I mainly took math and CS classes again. In terms of extracurriculars, I used to do some volunteering with local organizations in the Charlottesville area in Virginia. And I also participated as a member of Hackseval, which is a locally run student entrepreneurship org. So again, this is just my path on how I became a software engineer. Everyone has their own path, and everyone has their own path, their own unique interests and capabilities. So just you don't need to follow this path necessarily to get a role in computer science or a job in big tech or just tech in general. I know people with liberal arts degrees, for example, working in big tech, and people with CS degrees working in a non-technical field. The whole point of college and I guess high school a bit is to explore what you like and enjoy and find what you enjoy. And sometimes, like people who work in who pursue a CS degree, they don't necessarily they find out that they don't necessarily like doing a software job and find a different role instead. Same thing for the opposite always occurs as well with like people doing a liberal arts degree like in English or something, finding out that they actually also enjoy working with software and doing stuff outside of in their free time with computer science, and then eventually finding a role in a tech company. So again, just want to emphasize that college and high school is just should be a time for you to explore and fail without any without major consequences when you before you actually start working. And this is a key time for you to explore different activities and see what you truly enjoy. So a bit about myself. What my current role is at Amazon. So right now I'm at Amazon at AWS ECS. I started back in June 2021 during COVID. Um, so a bit of what I and my team worked on in the past year is region expansions. Amazon's constantly growing, and because of that, customers always want to be in a new region. They don't necessarily trust or want their data to be held in a new region. So this is always a big deal with customers in terms of getting a new region and building out all the existing Amazon services from the ground up, like EC2, Lambda, S3, ECS. All these services are built up from the ground up in a new region. So that includes like ordering the servers, the EC2 hosts that would run our service. So it's a lot of work to set up a new service in a new region. Other stuff that we worked on in the last year include new features, such as the update service mutability project, where we added support to update service to be able to mutate additional fields and parameters across an ECS service. Another feature that was worked on by the ECS org was adding Windows support for ECS exec, which is basically allowing a customer to execute commands via the command line on a Docker container for Windows on a Windows platform. So that was a very nice win for Amazon ECS. And another thing that's commonly worked upon is service re-architectures. As part of a cloud provider, cloud, I guess, has really only been a thing in the last 10, 15 years. A lot of cloud services like EC2, Lambda, ECS, they have all grown really quickly. And when growing really quickly to handle the needs of millions of customers, we usually accumulate a lot of tech debt, and usually don't follow the best design practices in terms of having like monolithic architecture, a huge basically service that is really hard to make changes to without also causing new bugs and stuff. So we've also been working on internally on a lot of different re-architectures to make our service more streamlined and basically more separated into more dedicated microservices. So that's a little bit about me and what I do as part of what I did in the past year as an engineer in Amazon ECS. So I'd just like to talk a little bit about the challenges and benefits with a career in cloud specifically compared to other tech roles that you may find. So benefits, it's customer facing and very high impact. So when I say we work with millions of customers, I mean it. We launch billions of tasks for customers every day, every week, and all the changes that you make, any new feature that you release, gets picked up by millions of customers. Even if the overall adoption rate is within the small percent, a couple of percent, for example, that's still a couple percent of a million is still 10,000 customers. So any change that you release will be tested end to end extensively by different customers with multiple different ways of how they use the service. Some customers that might use the service one way, and then another customer uses their service in a way that you don't expect your service to be used. And through all this like extensive testing, your service gets battle tested, and you basically learn a lot in terms of learning how to effectively scale up your service to handle millions of customers. And you basically you learn also a lot as you own a service end to end, especially in the cloud. I think just speaking from my experience, as an engineer in ECS, we have to own our service end to end. That includes setting up, like building out the individual code features, but also deploying these changes to customers worldwide in a gradual manner, and ensuring that any issues we see in this rollout of a new feature is dealt with effectively at a high priority. So this same benefit, though, in terms of being high visibility and high impact, is also a challenge. And that every change you make has huge impact to millions of customers. If you push out a faulty change that results in customers' services not working correctly, then you just cause a big outage for a lot of customers. Of course, we try to minimize this impact and blast by deploying to a specific region at a time and gradually. But there's a lot of I guess challenges with like dealing with customers if they get annoyed with your change you made, and that change breaks them. So there's a lot of visibility with working in the cloud, since you're effectively working with a customer, millions of customers. Unlike like if you, for example, work at Google Search, for example, you're just owning the search product that doesn't really get changed much, and the changes you make don't really affect the day-to-day operations of a customer. Like if we make a breaking change, for example, in a cloud provider, if Netflix goes down, then Netflix will be like, "What are we going to do? What are we going to do? We're gonna go to a different cloud provider and see if they work for us." So there's a lot of high visibility and challenges with working in the cloud. Additionally, since I guess working in the cloud, you enter into a relationship with a customer, an agreement with the customer to basically ensure that your service is up and running always. There's operational work on something called on call as well, where if a new customer issue is seen by us and reported to by a customer, we as an engineer have to engage and work and deal with this issue, ensure that this issue gets resolved and that the customer is not too heavily impacted by any change that we make or a new bug is discovered. So because of that, because of how we have customers worldwide, not just in the U.S., in Asia, Europe. Engineers have to be available across multiple hours. So that is one con in terms of sometimes you're occasionally woken up or interrupted in your evening, and you have to deal with this operational work in terms of dealing with this issue of customer say. But again, I think a career in cloud is very exciting in terms of what you can learn and the different lessons you can see in terms of owning cloud infrastructure and being able to roll it out and basically see how customers use your service. So I definitely think there's a lot of positives, and of course there's always downsides, but in any career. There's always downsides in any career. There's a lot of positives though in working in the cloud and seeing how you can continue to grow and learn as a software engineer. You'll definitely learn a lot in a career in the cloud, especially. Cool. Are there any questions, comments from the group, or anything you guys want to ask me? Questions are being asked in the chat, correct? If anyone has any questions.
I just want to say thank you for doing this, Philip. On my heart, like when you reached out to me Amazon, and just want to thank you for coming here. Thank you for doing this. If anyone does have any questions, please feel free to put them in the chat. But just before we ended, I wanted to say just thank you for coming out here and doing this.
Yeah, of course. It's not too much of a time effort, and I'm always helpful to provide my insights on what a career in cloud looks like. Cool. I think we have a question. How is career growth in the cloud world for the next few years? I would say it's a very exciting time to be in the cloud. The cloud world is definitely not mature yet. It's still definitely a fast growing startup like experience. I guess like my perspective in Amazon at least is that most Amazon services operate as their own mini startup. EC2 operates as their own company basically. ECS operates as its own company. Lambda, same thing as well. So all these companies are acting as their own agile startups, iterating on new features, reducing tech debt. and basically determining how the world looks like in terms of internet architecture, in terms of internet infrastructure, the next few years, how that paradigm would look like. So I do think it's a very exciting time to be in cloud, and I think compared to like a lot of other companies, the cloud is one of the few areas that's constantly growing. Just because there's a lot of demand from consumers and companies in terms of new customer workflows and new features being what they want to see built out in the cloud. I guess like in terms of like the bigger picture with like the overall economy, for example, there's like concerns like there's a recession going on, for example. But I know that in the cloud world, for example, hiring for engineers is always present, and it's definitely a very interesting time to be in the cloud. Cool. So we have a question from Jeff. As a software engineer, is there any special area that's more growing, like security or computing or database or so? So that's a good question. I wouldn't say there's a specific area that would be growing. Like that's growing at a significantly faster rate compared to other areas. I think they're all growing at a similar rate. Uh, and like independently, I guess like I would say don't pick if you're interested in like picking a role just because it's the most fastest growing role in software engineering, like security versus like computing. Don't pick something or gravitate towards something just because it's growing faster. I would say just find something that you're interested in um, and work with that field. Not everyone will like cryptography and like dealing with uh, bad actors in cybersecurity, for example. But I do think, just to address your point, and they're like what is growing quickly. I definitely think that they're all growing at a fairly even rate, and that regardless of what you choose, they'll all be necessary for uh, the future. Storage will always be necessary, and there's always different storage mediums that are being created by startups like Snowflake. Compute's always going to be necessary for like machine learning. Different machine learning workflows are constantly being onboarded onto um, cloud providers, and security is also constantly evolving with different cybersecurity with different like security issues cropping up and different attack vectors that that hackers or malicious actors are using. So I definitely don't see any harm in choosing any of these career areas for cloud or for software engineering. So next question is: does Amazon AWS allow internships for high school students or only college students? So I think for the most part, Amazon only hires college students. I know there are a few examples where I saw where a few of my high school friends, for example, got internships at Amazon as a high schooler. Uh, those are a bit rare though, very rare. They usually had experiences outside of like just high school to get them this role at Amazon as a high schooler. It's very rare. Stuff like I guess computing, like Usico, for example, that helped a bit. Prior software internships at other companies as a high schooler helped a bit. Uh, if you didn't have a high school internship, software internship, it's not likely that you'll get your first internship to be Amazon. I find that extremely unlikely. Um, but I do think that commonly, though, most companies, as a rule, prefer third years to hire as interns. And the reason why is because the whole point of internship is to convert interns into full time engineers. So if you hire an intern as a third year, in their third year, so in their last summer before senior, as a senior, they get extended. These interns get extended a full time offer, and they get converted back into a full time engineer immediately. So that's why you don't see as much priority for first and second year internships among tech companies, just because the best they can get from you on the next summer is another internship, which is only 3 months, and you can only do so much in 3 months compared to working as a full time engineer. Are there any other questions from the group or chat room? Okay.
All right. Yeah, you can go. I think if there's no more questions, then I think we can go ahead and wrap that up here.
Yeah, that
Yeah.
sounds good with me. Cool. Again, thanks everyone for listening to my talk. Hope you guys got some useful information from this talk. And thanks again to the High School Navigator program for inviting me to present on my experiences in the cloud and my journey to Amazon.